Hello everyone. So this is a question from NEET 2026. Consider the following reaction: 2A plus B giving us 2D, all of them in the gaseous state. Delta U naught is equal to minus 10 kilojoules per mole and delta S naught is minus 44 joules per Kelvin at 298 Kelvin. Identify the correct option with delta G naught for the reaction and spontaneity of the reaction at 298 Kelvin. Given R is 8.31 joules per mole per Kelvin. So the chapters involved is thermodynamics. So it is given to us that delta U naught, which is the standard internal energy change, as minus 10 kilojoules per mole. Okay. And delta S naught, which is the standard entropy change, is given to us as minus 44 joules per Kelvin. Be careful of the units. Okay. And you can see a negative sign is there in delta S naught because the number of gaseous particles are decreasing in the products. Here we have total 3, here we have 2. That's why the randomness is decreasing and hence delta S naught has a negative sign. Okay. So to calculate delta G naught, we can use the Gibbs-Helmholtz equation, or which is simply known as the Gibbs energy equation. Which is delta G naught is equal to delta H naught minus T delta S naught, right? But we don't know delta H naught in this equation. This guy we don't know, and this guy is the standard enthalpy change. We don't know this, but they have given us delta U naught. Okay, they have given us delta U naught, and also the reaction is given to us, which is useful. 2A gaseous plus B gaseous forming 2D gaseous. So we know that H is equal to U plus PV. We know this. Enthalpy is equal to internal energy plus the product of pressure into volume, right? At constant pressure, we can write at constant pressure, we can write delta H is equal to delta U plus P into delta V, where delta V is change in volume, right? So we can rewrite this equation as delta H is equal to delta U plus P into V2 minus V1, or we can expand it to write delta H is delta U plus PV2 minus PV1, where this V1 is the volume of gaseous reactants and this V2 is the volume of gaseous products. Okay, and for ideal gases we know that the ideal gas equation, which is PV is equal to nRT, right? So therefore we can write PV1 will be equal to N1RT, where N1 is number of moles of gaseous reactants. Very important. Number of moles of gaseous reactants. Similarly, we can write PV2 is equal to N2RT, where N2 is, this guy, is number of moles of gaseous products. Okay, so therefore we can substitute these values. That is, we can substitute PV1 here and we can substitute PV2 here. So we get delta H is equal to delta U plus N2 RT minus N1 RT. Okay, which we can write as delta U plus N2 minus N1 into RT. Okay, and finally we can write this as delta H is equal to delta U plus delta NG RT. This is a very important relation, okay, between delta H and delta U, where delta NG is equal to N2 minus N1. Okay, and delta Ng is the difference between number of moles of gaseous products and number of moles of gaseous reactants. Okay, so in our reaction, that is 2A plus B giving us 2D, you can see the number of moles, that is delta Ng, will be equal to, in the products we have 2 moles of gaseous products, therefore N2 will be 2. And in the reactants we have 2 moles of A and 1 mole of B, both are in the gaseous state, so total 3 moles of gaseous reactants. Okay, so therefore delta Ng is N2 minus N1. N1 is number of moles of gaseous reactants, which is 2 plus 1 3. So delta Ng will be 2 minus 3, which is minus 1. Okay, so therefore now we can substitute, we can use this equation. Okay, um, we know that during standard conditions we can write this as delta U naught plus delta Ng RT. Okay, so delta H naught we don't know. Delta U naught is given to us, which is minus 10 kilojoules per mole. Be careful. Delta Ng is minus 1, and R they have asked us to take as 8.31 joules per mole per Kelvin, and temperature is 298 Kelvin. Okay, so therefore we need to convert this guy into joules because everything else is in joules. Okay, so upon converting to joules, it will become minus 10,000 joules per mole minus 8.31 into 298 joules per mole, because this Kelvin gets cancelled. Okay, so when you do this calculation, that is minus 10,000 minus 8.31 into 298, you will get delta H as minus 12,476.38 joules per mole. Okay, so now we know delta H naught, and we can use the Gibbs energy equation, that is this equation, okay, to find out delta G naught. So we know that delta G naught is equal to delta H naught minus T delta S naught. Delta H naught we just calculated as minus 12,476.38 joules per mole. So minus 12,476.38 joules per mole minus temperature is given to us as 298, and delta S naught is given to us as minus 44, and the units of delta S is joules per Kelvin. Okay, so when you do this calculation, you will get minus 12,476.38 plus 298 into 44. So you will get your answer as, when you do this calculation, you will get it as 635.62 joules per mole. And to find it in kilojoules per mole, because all the options have, the value in kilojoules per mole, so what we do is 635.62 into 1000 divided by 1000 joules per mole, which is not going to change anything. And we know that 1000 joule is 1 kilojoule, so this becomes 1 kilojoule, and we are left with 635.62 divided by 1000, which is 0.63562 kilojoules per mole. So this is the delta G naught value in kilojoules per mole. Okay, and regarding the spontaneity, and spontaneity is whether a process can take place by itself or has the tendency to take place. Okay, the criteria in terms of free energy change is that if delta G naught is negative, then the process is spontaneous. If delta G naught is 0, then the process is in equilibrium. And if delta G naught is positive, then the direct process or the forward reaction is non-spontaneous. Okay. So in our case, delta G naught in our reaction is positive, that is plus 0.63562 kilojoules per mole. So therefore, our reaction in the forward direction is non-spontaneous. Okay. So therefore, 2A plus B giving 2D is non-spontaneous in the forward direction. Okay, so therefore delta G naught is plus 0.63562 kilojoule per moles and the reaction is non-spontaneous. Okay,